In this example, we have a number of data, a number of observations in a sample here, where we measure the certain metabolite in the blood of a group of patients, and we want to compare this sample with a reference value. And this is a very common problem where you have some samples and you want to compare it with a reference value. So you basically have one sample and you want to do a test with that. However, the problem is that Excel doesn't have a special function for one sample t-test, so we have to do a little bit of tricksing. But first of all, let's write down what we would write as null hypotheses in a case like this. So we would say our null hypothesis is basically we assume that the sample is drawn from a population that has a population mean. So this is the population mean from which the sample is drawn. And we say that this population mean is the same as our reference value, 105 microgram per liter. And any differences from 105 is just simply due to sampling error. Likewise, we can write our alternative hypothesis, and we just simply say that the population mean from which the sample is drawn is not the same as the reference value. So the way we can do that is we just simply can calculate a p-value for that. But how are we going to do that? Because we can calculate p-values with the functions in Excel only if we have two samples. So, well, what we can do is we just simply say, well, we just assume a second sample where we have the reference value. And all we need to do is really we add two of the reference values, and now we can perform a t-test. So here the way we do that is we use the built-in function in Excel equals t-test. So here we have the t-test. Here is our first data set, array 1, separated by a comma. Here is our second data set. Very small one, but nevertheless it is one. And now we need to ask how many tails do we want to have this distribution. And since we formulated our alternative hypothesis that it should not be the same, this could mean that mu1 is either larger than the reference value or it is smaller than the reference value. So this indicates that we have two tails here. And I would always go for two tails in a case like that. And now, last one, it is asking us about the type of this test that we want to do. Our data are certainly not paired. We can also say with a certain certainty that the two sample variances won't be the same. So we definitely go here for the two sample unequal variances. So that is type 3. And here we get a p-value of 0.0049. So this here is our p-value. So p equals 0.0448. Now what does that mean? We know that if p is smaller than alpha, and alpha here is set to 5%, so that is 5%, or I can write this also as 0.05. If our p-value is lower than alpha, then we have, if p is low, h naught must go, and we have 0.0048 is certainly smaller than 0.05. So that means we can safely reject our null hypothesis, and we can say that most likely the sample mean that we calculate for our sample is not close to the reference value. Now let's just simply calculate quickly a confidence interval for our sample here. So we calculate the average, or the mean of our sample, so equals average, we just type, and Excel will come up with the right function. We highlight the cells here. So here our average is 167.3, and very clearly this is not even close to our reference value of 105. Now let's quickly calculate the standard deviation, and here we are dealing with a sample standard deviation. So here equals standard deviation, and we are using the standard S here. Again, we highlight the cells. So that is our standard deviation. And what we can do now is we can calculate a confidence interval, or we can do a margin of error here. So this is done with the confidence, and because we are dealing with a sample where we don't know the population standard deviation, we use confidence T. So it asks us for our alpha, this was 0.05. It asks us for the sample standard deviation, that is what we just calculated, that is this one here, and it asks us for the sample size, and we had 1, 2, 3, 4, 5 individual observations. So our margin of error is 30.5. Now we can calculate the upper and the lower bound for our confidence interval. So here the upper bound is just simply our average plus the margin of error, and the lower bound is the average or the mean minus the margin of error. So here our interval, our 95% confidence interval, goes basically from 136.8 to 197.9 microgram per liter. So we are confident that 95% of the population, that 95% of our data are in this confidence, in this 95% confidence interval. Now, we also know that our reference value is 105 micrograms per liter, which is way out of this confidence interval. And this basically confirms that the reference value is way out from the confidence interval where we are fairly sure that the population mean for our sample is located. So this means that the reference anti-confidence interval do not really match with each other, and therefore there is a significantly statistically significant difference between the reference and the sample mean.